Have you ever looked up at the night sky and felt a sense of wonder? It's a vast, dark canvas sprinkled with countless stars. And for as long as we have been human, we have asked a simple, profound question. Are we alone? This question is at the heart of one of the greatest scientific puzzles of our time, often called the Fermi paradox. The universe is incredibly old and mind-bogglingly big. There are billions of galaxies, each containing billions of stars. Many of those stars likely have planets orbiting them. So with all that cosmic real estate, where is everybody? The silence from the cosmos is deafening, leaving us to wonder if we are the only intelligent life around. But what if the answer isn't out there among the distant stars, but right here in our own cosmic backyard? What if other civilizations, ancient and advanced, have already come and gone? Perhaps they visited our solar system millions or even billions of years ago. They might have left something behind. Not a crashed saucer or a secret alien base, but something more subtle. Something designed to last for eons. A message in a bottle, floating in the vast ocean of space, waiting for a young, curious civilization like ours to find it. This idea sounds like science fiction, and for a long time it was. But a growing number of serious scientists are starting to take this possibility seriously. They aren't looking for little green men. They are looking for artifacts, technological relics left by visitors who passed through our neighborhood long before we ever looked up. But what exactly is an orbit? Imagine you throw a ball. It flies for a bit, then gravity pulls it back down to Earth. Now imagine you could throw that ball so incredibly fast that as it falls, the Earth's surface curves away beneath it at the exact same rate. The ball would just keep falling forever, constantly missing the ground. That is what an orbit is, a state of continuous freefall around a massive object, like a planet or a star. Most orbits, however, are not perfectly stable over very long periods. Think of our solar system as a busy, chaotic highway. There are planets, moons, asteroids, and comets all pulling on each other with their gravity. An object in a simple orbit around the Sun will get nudged and tugged by Jupiter, pushed a little by Mars, and pulled by Earth. Over thousands or millions of years, these tiny nudges can add up. This is why finding a truly stable orbit, a cosmic parking spot, is so special. These are the places where the gravitational dance is so perfectly balanced that an object can stay put for billions of years. And our solar system, it turns out, is full of these perfect hiding places. One of the most fascinating examples of stable orbits comes from a concept discovered over 200 years ago by a mathematician named Joseph Louis Lagrange. He was studying the gravitational interactions between two large bodies, like the Sun and the Earth. He found something amazing. He realized there were 5 special points in space where the gravitational pulls of the Sun and the Earth, combined with the centrifugal force of a smaller object's orbit, all balanced out perfectly. 2 of these points, called L4 and L5, are particularly stable. They form a perfect equilateral triangle with the Sun and the Earth. If you put something at L4 or L5, it will stay there indefinitely, like a loyal cosmic companion, leading or trailing the Earth in its orbit around the Sun. In fact, nature has already used these spots. We have discovered clusters of asteroids, known as Trojan asteroids, that are trapped in the L4 and L5 points of Jupiter, Saturn, and even Earth. The incredible stability of the L4 and L5 points makes them ideal candidates for hiding an ancient artifact. They are natural parking garages in space. Anything left there would be protected from drifting away, requiring no fuel or maintenance to stay in place for geological ages. The James Webb Space Telescope is actually parked at the Sun-Earth L2 point, taking advantage of its stability. What if, while it's looking out at the distant universe, we should also be looking right next to it? Beyond the elegant stillness of Lagrange points, there's another, more dynamic type of stable orbit that has really captured the imagination of artifact hunters. These are known as co-orbital configurations. It's kind of like 2 runners on the same circular track who are, in a way, tethered by an invisible elastic cord, always staying near each other. One of the most interesting is the horseshoe orbit. An object in this kind of orbit will slowly drift towards Earth from behind, but just as it gets close, Earth's gravity gives it a little nudge. This nudge gives the object a bit of energy, pushing it into a slightly larger, slower orbit. From Earth's perspective, the object appears to trace a giant horseshoe shape. What makes these co-orbital paths so compelling is that they are remarkably stable over long timescales. We've already discovered several of Earth's co-orbital companions, like the asteroid 2020 XL5. These objects are a bit like neighbors who live on the same street but never quite visit your house. They're close, predictable, and they stick around. An advanced civilization could have placed a probe in a horseshoe orbit, knowing it would remain near Earth for millions of years without needing any course corrections. It would be a patient sentinel, just waiting for us to become advanced enough to notice it. The notion that alien artifacts might be hidden in our solar system sounds like a modern sci-fi plot, but its roots stretch back further than you might think. It emerged in the mid-20th century, a time of great scientific optimism and discovery. The space race was just beginning to heat up, and humanity was taking its first tentative steps beyond Earth's atmosphere. During this era, scientists began to seriously consider the possibility of intelligent life elsewhere in the universe. The most influential and well-defined version of this idea came from radio astronomer Ronald Bracewell in 1960. He published a groundbreaking paper that proposed a specific type of artifact we should be looking for: an autonomous, intelligent probe. He imagined that a long-lived technological civilization wouldn't try to communicate across the vastness of space and time with radio signals. Instead, they would dispatch robotic messengers to other stars. These Bracewell probes would be galactic explorers, programmed with a simple yet brilliant mission: find a star system with a planet that shows the potential for life, enter a stable orbit, and wait patiently for that life to become intelligent. For us, that trigger would have been the first radio waves we began broadcasting into space about a century ago. Upon detecting these signals, the probe would wake up and initiate contact, perhaps by repeating our own signals back to us. Modern searches for extraterrestrial artifacts are all about data, immense amounts of it. Sky survey projects like the Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona scan the heavens every single night. Their primary mission is to find near-Earth asteroids that could pose a threat to our planet, but in the process they create a colossal catalog of every moving object they can detect. This data is a treasure trove for space archaeologists. So what does an anomaly look like in a database of rocks and ice? Scientists are looking for objects with unusual orbital characteristics. Most asteroids follow predictable paths dictated by the gravity of the Sun and planets. An artifact, however, might be in a highly peculiar orbit, one that is very stable but not easily explained by natural processes. Another red flag would be an object that changes its trajectory. Beyond an object's movement, its physical properties are also a key focus. Telescopes can measure how an object reflects light over time, which creates a light curve. We can also study the spectrum of the light reflecting off an object. This tells us what it's made of. If we found an object made of refined metals, like titanium or stainless steel, or elements that are rare in asteroids, it would be a dead giveaway that we were looking at something artificial. In 2017, our solar system received a visitor unlike anything we had ever seen before. It was a small, dark object that came speeding in from interstellar space, from the direction of the star Vega. Astronomers named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. At first, they thought it was just another comet or asteroid, but the more they studied it, the stranger it became. For one thing, it had a very unusual shape. Based on how its brightness flickered as it tumbled, scientists calculated it was extremely elongated, perhaps 10 times longer than it was wide, like a cosmic cigar or a flat pancake. But the weirdness didn't stop there. As Oumuamua looped around the Sun and began its journey back out of our solar system, it did something truly bizarre. It gently accelerated, pushing away from the Sun with a tiny but measurable force. Comets do this all the time. As the Sun heats them, ice turns to gas and shoots out like a tiny rocket engine. But astronomers looked very closely at Oumuamua with our best telescopes, and they could see no tail, no fuzzy coma, no sign of any outgassing at all. It was accelerating without any visible means of propulsion. This mysterious push, combined with its strange shape, led some scientists, most notably Harvard astronomer Avi Loeb, to ask a provocative question. What if Oumuamua was not a rock, but a piece of alien technology? Loeb proposed that Oumuamua could be a solar sail, a type of spacecraft that uses the pressure of sunlight to move, which would explain its acceleration without outgassing. Or perhaps it was a defunct alien probe, tumbling silently through the galaxy for millions of years until it happened to pass through our solar system. Most scientists disagree, suggesting more conventional, though still unusual, natural explanations. But the debate itself was a landmark moment for the field of space archaeology. Oumuamua was a real object that sparked a serious, mainstream scientific discussion about the possibility of an extraterrestrial artifact in our own solar system. We will never know for sure what Oumuamua was. It is long gone, speeding away into the darkness, never to return. But its brief, mysterious visit served as a powerful reminder. It showed us that strange things are out there, and it sharpened our curiosity. The search for silent visitors is entering a new and exciting era, powered by a new generation of tools and a new generation of scientists. Perhaps the most significant development on the horizon is the Vera C. Rubin Observatory, currently under construction in Chile. Starting in 2025, the Rubin Observatory will conduct the Legacy Survey of Space and Time, a 10-year project to photograph the entire visible night sky every few nights. The sheer volume and detail of the data it will collect are unlike anything we have ever seen before. A team of scientists, including Dr. Avi Loeb of Harvard's Galileo project, is already developing software designed to comb through the LSST data specifically to flag any object that looks or moves in an anomalous way. The Galileo project itself represents a major shift in the scientific community's approach to this topic. It is the first well-funded mainstream scientific research project dedicated to the systematic search for evidence of extraterrestrial technology. The project aims to use a network of state-of-the-art telescopes and instruments to follow up on any unusual objects identified by surveys like the LSST. What if the search pays off? What if the Vera C. Rubin Observatory flags an object with a strange, non-gravitational movement? The discovery would be, without exaggeration, the single most profound moment in human history. It would fundamentally change everything we thought we knew about our place in the universe. The silent cosmos would suddenly have a voice, even if it's just an echo from a civilization that disappeared a billion years ago. The question, "Are we alone?" would finally have an answer. No, and we never were. The search for extraterrestrial artifacts transforms the vast, silent expanse of our solar system into the next great frontier of human exploration. It is a quest driven not just by scientific curiosity, but by a profound philosophical yearning to know our place in the grand cosmic narrative. Whether we find a message in a bottle or only the silent, indifferent beauty of nature's own handiwork, the act of looking changes us. It fosters a sense of wonder, a spirit of patient inquiry, and a global perspective. The sky above is not just a ceiling, it is an archaeological site, and we, the new generation of cosmic detectives, have only just begun to dig for the secrets it holds. The search for these hidden objects is more than just a scientific curiosity. It is an expression of our deepest desire to connect, to understand our origins, and to know our place in the cosmos. And reading it would change the course of human history forever.